Hey everyone, welcome back, and today let's solve Leetcode problem 1957 titled Delete Characters to Make a Fancy String, the Daily Leetcode Problem Challenge on Leetcode. So just a quick note, I am actually recording this video on the day of Halloween, so just disregard the background noise of people just screaming trick or treat and yelling in the background here. Hopefully it isn't too disturbing if you guys can hear it and if my microphone actually picks up those noises. So anyways, let's just go ahead and dive straight into the code here. So a fancy string is a string where no three consecutive characters are equal. So we're given a string S and we need to delete the minimum possible number of characters from S to make it fancy. And we have to return the final string after the deletion. And it can be shown that the answer will always be unique. Okay. So in example 1, we have the input string S to be Leetcode, but we have an extra E here. We have, instead of 2 E's, we have 3 on index 1, 2, and 3. And so we'd output just the regular Leetcode, kind of just effectively removing this extra E, right? Because if we remove an E from the first initial group of E's, we can create Leetcode. And no three consecutive characters are equal, and so we can return Leetcode, right? Because as you can see, if we just traverse through this output here, we'd see that we don't actually have three consecutive equal elements. In example 2, we have the input string S to be A, B, A, and we'd output A, right? Again, no three consecutive elements are actually equal, right? We can remove an A from the first group of A's, and then we can remove two A's from the second group of A's, and so we get the following string A, rather, right? And again, if we were to traverse through this, no three consecutive elements are actually equal, and so we can return this value as the minimum number of characters to make it S, right, that we remove. And finally, in example 3, we have the input string S to be AAB. I mean, that's already fancy. We don't have any three consecutive characters that are actually equal in the original input string, and so we don't have to actually make any modifications or deletions, and so we can simply output the string immediately without actually having to worry about any cases where we have these consecutive three equal elements. Wow, I just realized I've been saying that quite a lot. Okay, so with that out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so it can actually be a little misleading when it says we have to return the final string after the deletion of elements from the input, because usually, as a kind of general rule of thumb in programming, you don't want to delete elements from an iterable as you actually iterate through it. That's going to create some disruptions and errors in your traversing of the data structure, and it's going to kind of make it a little bit weird. So instead, I'm just going to add valid characters that don't actually form a three-peat, is what I'm going to call it, basically three consecutive elements that aren't equal, and I'm going to add these valid characters to a result, which I'm ultimately going to return the string of, okay? So how do I actually format this? Okay, I'm just going to initialize my result, and it's going to be initialized to an empty list because, of course, we haven't actually traversed through the input string S yet. And then we can simply traverse through the input string S regularly. So I'm going to say for I in the range of the length of S, which again, note, is going to be our input string. Now, sure, we can add to a result. So result.append S at I. But there is a case, result.append S at I. But there is going to be a case here where we can't do this. What is that case? When the current element that we're looking at forms a three-peat. Again, three consecutive equal elements. So how do we actually handle that? Simple. We need to check if the most recent two elements that we've added to the result, if they're equal to the current element, because again, we're traversing through this sequentially, then we know that the current element is going to be a potential former of a three-peat, because the most previous two elements, or the last two elements we've added to the result from the previous iterations of our input string S, since they're equal to the current element, and they're going to form a consecutive sequence of three, then we know that this is going to form an actual three-peat. And so we want to avoid that and simply continue to the next iteration, or to the next index I. So how do we actually keep track of that? Well, that's simple. If S at index I, the current index or the current element that we're looking at in this iteration of our traversal, if that's equal to result at -1, which is equal to result at -2, in Python this is pretty nice. We can kind of directly compare it like this. if it's equal to result of -1 and result of -2, the two most recent elements that we've added to the result list in previous iterations. If that's the case, we simply have to continue. But there is another error here. What is the error? We can go out of range, or we can have an index out of range, because what if the length of the result at this point, or in this iteration, what if it's not even equal to 2? What if it's less than 2? We don't even have two elements to compare the current index to, and so we have to have another conditional. If the length of our result at this current point, if that's equal, or rather greater than or equal to 2, so we do have valid elements to actually check, and the current element at index I is equal to the previous two elements that we've added to the result, or the two recent elements that we've added to the result, this is going to form a potential 3P, and so we simply have to continue or move on to the next iteration and check if that's going to form a 3P either. And if it isn't, we can add it, essentially marking that it is a valid element, that doesn't actually form a 3P. And ultimately, outside of this for loop, once we're done traversing through all the elements in our input string S, we can simply return the list, because it would have eventually stored, result rather. It would have eventually stored all the valid elements that don't form a 3P in our input string S, or rather from our input string S that have been added to the result, as long as they're actually valid, which again is defined to be an element that doesn't form a 3P, which we check on line 5. But there is another quick error here. If we actually were to run this right now, it wouldn't be accepted, because we just simply return a list of strings. As you can see, these elements or strings do match the current elements or correct characters in our expected output, but they're a list. We don't want these individual characters to be separate elements in a list that we return. We want it to be a simple string as a whole. So how do we do that in Python? It's pretty simple. We use the string.join method. So we say the string.join of the result, which again, this is simply going to join or concatenate all of these separate or individual elements from this result list and combine them to be a single string, right? Which is pretty self-explanatory how that works, and it is a pretty good feature to know. I've used it a lot in Leetcode problems, or not a lot, but a good amount, even on my channel, and so I think it's a pretty good feature to at least be familiar about and know how that works, right? So now, as you can see, if I were to submit this right now, okay, now it should work. And as you can see, this is pretty efficient code. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Oh yeah, I almost forgot to talk about the space and time complexity. This is going to be a big O of n complexity for the time, because of course this is a one-pass solution. We iterate over our input string S once, and for the space complexity, it's also going to be big O of n, because worst case, none of the elements are actually invalid, none of them actually form a 3P, and so we just return or store all of the elements from our input string S into the result and return that. So this is going to be a linear time solution, or a big O of n solution, for both the runtime complexity and the space time complexity for the memory. So if you guys enjoyed this solution and learned something new, please consider liking this video, and without further ado, I will see you guys in the next video. Bye-bye.